Okay, let's take a look at the first example, titration of a strong acid by strong base. Here we have a titration curve, and we have the analyte, which is a strong acid. Okay, so at the beginning, before we add any NaOH, the strong base, the pH will be below 7. Okay. As we start adding more NaOH into the solution, the pH will increases, and then there'll be a big jump. And after that, you add more base, it will start saturating at a higher pH, a basic pH solution. Okay. So we have 4 regions that we want to find out. Okay. The first question: does the initial pH make sense? Okay. So let's take a look at this. So we have the concentration of HCl in this particular example equal to 0.1000 molar. Since HCl is a strong acid, it will be 100% dissociate into water. That means the amount of H plus will be the same as 0.100 molar. As you know, to calculate the pH of a solution, meaning pH equal to negative log of the concentration of the hydronium ion, that gives you negative log of 0.1000, that gives you of pH 1. So once again, if you look at the titration curve right here, before I add any NaOH, the pH is 1, so that makes sense. Now for the second question, what will be the pH at the equivalence point of a strong, when I have a strong acid titrated by a strong base? The answer will be pH equal to 7. Why is that? Well, in this particular example, we have HCl plus NaOH making NaCl plus H2O. Okay, we have a strong acid, strong base. We are making a sodium chloride salt and H2O. NaCl salt in solution, meaning we have Na plus and Cl minus. Both of these ions in the solution will not affect the acidity of the solution. In that case, that means it will be neutral, because water will be neutral, Na plus and Cl minus, they will not affect the pH of the solution. Okay. Now, that means we need to talk about equivalence point. Once again, equivalence point means the most of the OH minus equal to the most of hydronium ion. Okay, so in this case, the amount of HCl and OH minus will be the same, and that's why you have pH equal to 7. Now the question will be, okay, how do I know how much of a strong base do I need to add in order to reach the equivalence point? Well, let's look at the information given from this particular problem. We have a 40 ml of 0.1000 molar of HCl, and we are adding 0.1000 mole of NaOH. What you realize that since they're the same concentration of 0.1 molar, if I need 40 ml of HCl, 0.1 molar of HCl, I will also need 40 ml of 0.1 molar NaOH in order to completely neutralize the HCl and NaOH. So if you look at the titration curve, you realize at 40 ml added NaOH, you see they will get to the pH equals 7. That will be our equivalence point. And that answers the first 2 questions of the titration of a strong acid by a strong base.